Hello everyone. So today we're going to go over the second part of the Unit 9 practice test, the written portion. Problem number 1. We're matching graphs to equations. So if we look at the equations here, we have the 4. And the base is either 3 or 1/3. So if we look at the 4 graphs, there's only one that is negative, and that is graph D. So that must be y equals to -3 to the x. So that is equation number 3. Okay, so secondly, there are two functions that have a coefficient of 3. These two here. The first one has a base of 3, so it must be increasing, and it has a y-intercept of 3. And the second one, equation number 4, has a y-intercept of 3 and a base of 1/3, which means it must be decreasing. So what that means for us is that graph A must be y equals to 3 times 3 to the x, the increasing function, and graph B must be y equals 3 times 1/3 to the x, the decreasing function. So this would be equation number 2 and number 4 respectively. And the last one we have is C. So this is the one that has a y-intercept that's 1/3. So that's y equals to 1/3 and then 3 to the x. The 3 makes it so that it is exponentially increasing, the base of 3. So this is equation number 1. And that's it. So let's move on to problem number 2, solving for n. So for questions like these, we're looking for a common base. In this case, we can use the base of 3. Of course, 9 is equal to 3 squared. And then on the right-hand side, 1/3 is 3 to the -1 power. So that means on the left-hand side, we have 2 times n minus 1. And on the right-hand side, we have negative, and then in parentheses, 4n minus 1. So now we can solve for n. So on the left-hand side, we have 2n minus 2. And on the right-hand side, we have -4n plus 1. So moving the terms with n to the left-hand side, we have 6n. And then on the right-hand side, we have 3. And we do so by adding 4n to both sides and then adding 2 to both sides. And finally, if we divide both sides by 6, n is simply equal to 1/2. Okay, and that's it. Number 3. This one is about the transformation of the exponential function. Now, let's look at it one at a time. So the first transformation is simply a reflection in the y-axis. So the x in the equation becomes negative. That's it. Next one, if we were to take y equals 5 to the x and shift it 3 units to the right, then we'll have y equals to 5 to the power of x minus 3. 1 unit down and 4 units to the left, so very similar to B. So we have y equals to 5 to the x plus 4 power for that part, and then minus 1 to move it 1 unit down. And finally, the last part, reflection in the x-axis. So that would give us -5 to the x, of course. And finally, 2 units down, we have a -2. And that's it. Number 4. Okay, so we're going to rewrite the function given here in a different form, not necessarily the form that's given here, but a more useful form for graphing. So here we're going to factor out the -2 from the exponent part. So we have -2 and then in parentheses x minus 2 and a plus 6 after that. So then what we can do is we can then subtract both sides by 6 and multiply both sides by -2, which gives us this form, -2 and then y minus 6, and that's equal to 2 to the power of -2 x minus 2 in parentheses. Doing this allows us to describe the transformations a little bit easier. We can see that originally x now is rewritten as -2 and then x minus 2. So that means 3 transformations have occurred. Number 1, there is a reflection over the y-axis. Secondly, there is a horizontal stretch by 1/2. And finally, the graph was moved right 2 spaces. Now we can look at the y variable as well. It transformed from y to -2 and then y minus 6. So we also have a reflection over here, reflect over the x-axis. That's one part. There's a vertical stretch by 1/2. And finally, the graph was moved up 6 spaces. So if we were to graph the function, we can make a table of values first for the original function, and that is y equals 2 to the x. Let's go ahead and do that here. So let's go with 0, 1, 1, 2. 2 squared is 4. 4. Sorry. 2 cubed is 8. Sorry about that. And 2 to the 4th power is 16. And then we are looking at some transformed values. So make a second table of values to the right. Just like that. X and y once again. And so let's say, for example, we have the point 0, 1. The x-coordinate 0 will undergo the reflection over the y-axis and a horizontal stretch by 1/2, which doesn't change the value of 0. And then it will be moved to the right 2 spaces, so the x-coordinate becomes 2. The y-coordinate, we reflect over the x-axis, so -1, and then a vertical stretch by 1/2, so it becomes -1/2, and then it will move up 6 spaces, so -1/2 plus 6 gives us 5.5. So that will be the first point on the new function. So 2, and then 5.5. Right here. So the next point, very similar. We start at 1, becomes -1 because of the reflection, and then -1/2 because of the horizontal stretch, and then plus 2. So -1/2 plus 2 is 1.5. The y value, we start with 2, reflect over the x-axis gives us -2, and then the vertical stretch by 1/2 gives us -1, and finally -1 plus 6 gives us 5. And the same thing can be done for the rest of the points. So the point 2, 4 will become 1, 4. The point 3, 8 will become 1/2, 2. And finally, the point 4, 16 actually becomes 0, negative 2. All right, so if we were to go ahead and plot these, so 1.5, 5, 1, 4, 1/2, 2, 0, negative 2, 2 down here. And of course, we have an asymptote at y equals 6. Because the graph was moved up 6 spaces. And now we can connect the graph points to make a smooth curve, and that is our function. And that's it. So let's move on to problem number 5. Okay, so a vehicle was purchased for $35,000. Sorry about that. It depreciates 20% every year. So if we were to write an equation for the value b, that will be equal to the initial value, 35,000, and then every year it loses 20% of its value, so that will be 1 minus 0.2, 20%, to the t power, t in years, of course, which could be simplified to 35,000 and then 0.8 to the t power. So first question, 2 years after the car was purchased, so that would be simply 35,000 and then 0.8 squared. And if we were to multiply this out, this would be $22,400. And then for the next part, approximately how long will it take for the vehicle to depreciate to $3,000? So again, we're going to use systematic trials here. So a bit of trial and error. And we'll find that if we let t equals to 11, we'll get a value of $3,006.48. So about 11 years is how long it will take for the vehicle to depreciate to $3,000. Okay, just to reiterate, once we complete the next unit, there will be a easier way of doing this question instead of trial and error or systematic trials. Okay, number 6. So cobalt 60 has a half-life of 5.3 years. Sample of 60 milligrams is present today. So the amount left will be equal to 60, which is the initial value, multiplied by 1/2, because this is a half-life question, and then n over 5.3, where n is the unit of time that we're going to be using, which is in years. So what amount will be present in 10.6 years? Well, we can simply substitute for this one. So 10.6 over 3.5, sorry, 5.3, sorry about that, which of course simplifies to just 2, so 60 times 1/2 squared. So 60 times 1/4, which gives us 15 milligrams. Okay, part C, how many years would it take for the amount of cobalt 60 to decay to 12.5% of its initial amount? So for this one, 12.5% is equal to 1 over 8, which is equal to 1/2 to the third power. So that means for the amount to decay to 12.5% of the original, 3 half-lives must have happened. And that would be 3 times 5.3, which is 15.9 years. All right. So let's look at the last question. We are given the equation to find compound interest and amounts. So here it is. See here, A is equal to 1,300 is the initial investment. We have 1 plus, and the interest rate is 3%, so 0.03. And it's compounded quarterly, so n is going to be equal to 4. There are 4 quarters in a year. And this will be multiplied, to the power of 4t, which of course can be simplified. So this is just A is equal to 1,300, and then 1.0075 to the 4t power. Let's see, after 8 years, we can simply substitute in 8 for t. So A is equal to 1,300, and then 1.0075 to the 4 times 8 power. So then that will be A is equal to 1,300, 1.0075 to the 32nd power, which we can evaluate using a calculator, and that will give us approximately $1,651.14. So, given our answer from part B, it asks in part C how many years approximately will take for the investment to have a value of $1,600. So it's going to be less than 8 years. So let's try 7 years and see what happens. And so if we did that, 4 times 7, we will actually get a value of, again, approximately $1,602.53. So the number of years would be 7. Okay, so in a way, the written questions can be divided into 3 parts. Ones that are about exponential functions and their graphs, ones that are about solving exponential equations algebraically using common basis, and finally our application or word problem section. And that's it. So that's it for today. Once again, thank you for listening.